Alright, hello everyone. So today we're going to be doing notes on mean absolute deviation. So before we dive into what it actually means for what it means to find the mean absolute deviation, I want us to look at the word deviation so that we have a better understanding of what we're actually trying to find. So to deviate, it means you stray or depart from the normal course of action. So when if I say that, oh, she deviated from her schedule, that means that she strayed or she departed from her regular schedule. So if it means that if we're trying to look for a deviation of something, that means we're going to be looking for a change or a departure from the normal course of action. So knowing what deviation means, we're going to look at what our actual concept is today that we're going to be learning, which is mean absolute deviation, which is lovingly acronymed as MAD, which I think is pretty funny because I already know, looking at this concept, it's going to make a lot of you mad. The only reason why I say that is because it's not necessarily a difficult concept to understand. It's more that it's a tedious thing to do. The amount of steps you have to take to get to the mean absolute deviation can make a few of you a bit upset. But please don't be alarmed. Please don't stray away from learning this, because it is a really easy concept to understand because it uses easy operations. It's mostly finding the mean of a mean or the average of something. So you're not going to have a difficult time, but I know that some of you might get mad at just how tedious it is and how much work it is. But it is something important that we need to learn in statistics. So the mean absolute deviation. So we already know what mean is. Mean is the average. So it is an average of how much the data values differ, and that's where we get our deviation, from the mean. Okay, I'm going to repeat that again. The mean absolute deviation, or MAD, is an average of how much the data values differ or deviate away from the mean. Okay, so steps to find the mean absolute deviation, or MAD, is a 4-step process. So before we start actually looking for it, I want us to go through each step. So the first step is you're going to find the mean of the data, which you already know how to do. The mean is you're taking the sum of all the data, then dividing it by however many numbers there are in the data. Okay, it is not the same as the median. I repeat, mean and median are not the same thing. Mean is the average, median is the middle. Okay, so we're looking for the mean. Okay, second step, we're going to find the distance between each data value and the mean. So we're going to find the distance between each value in the data set and the mean of that data set. Step 3, we're going to find the sum of the distances in step 2. So all the distances we find in the second step of our process, we're going to find the sum of it. Okay, for number 4, step 4, we're going to divide the sum in step 3 by the total number of data values. Running out of room, but that's okay. There you go. Okay, so that's our 4-step process. You're going to find the mean of the data, then find a distance between each data value and the mean, then find the sum of the distances in step 2. Then step 4, we're going to divide the sum in step 3 by the total number of data values. So let's go into our first example. Example A, finding the MAD of a data set. So let's say you're eating some Lucky Charms and you decide you want to record the number of marshmallows you find in 8 scoops of cereal. Why you would want to do that? I'm not sure, but hey, you never know. So when you record the number of marshmallows in your cereal, your 8 scoops of cereal, you'll see all the marshmallows that you found in each scoop. So step 1, we're going to find the mean or the average. Now, you'll notice that my numbers are already put in order. So here's the thing though. When you're trying to find the mean of a data set, you do not have to put the numbers in order from least to greatest. You do not have to when you're trying to find the mean of the data set. You absolutely do not have to find them. Again, you do not have to put the numbers in order from least to greatest when you're trying to find the mean. Now, you do need to put the numbers in order when you're trying to find the median, okay? So I'm going to repeat that again. When you're finding the mean of a data set, you do not have to put the numbers in order from least to greatest. When you're finding the median, you do have to put the numbers in order from least to greatest. Now, this data set right here is already put in order. But did we need to have it? Did it need to be in order? Not really, but that's okay. All right, so we have our numbers here in our data set. So step 1, we need to find the mean. So pause this video now and I want you to see if you can find the mean on your own without my help here first. So pause the video and try to do it on your own. Okay, so I hope you've already unpaused the video and you're checking your work now. So for the mean, it's the sum of all these numbers divided by however many numbers there are. So I'm going to add all of them together. And then we're going to divide it by however many numbers there are. There is 1, 2, 3, 4, 5, 6, 7, 8. 8 numbers. And see, 8 scoops of cereal. Okay, so when we add all these numbers up together, you should have gotten the number 24. Okay, and 24, we're going to divide that by 8 because that's how we find our average or our mean. Okay, 24 divided by 8 is 3. So now we know the mean of this data set is 3. Now, for step 2, we need to find the distance between each data value and the mean. So we know that mean equals 3. So I put data, mean, and distance from mean here because I'm breaking it down into a table format. Now, do you need to do this every single time? No. But does it help you organize your data and the mean and the distance from the mean? It definitely helps you organize your answers. So that's what we're going to do. So I'm going to list down all of our numbers in our data set. And if you hear weird noise in the background, that's just my dog just trying to get her food. Okay, so I listed all the numbers from our data set. And then I'm going to list down our mean. So our mean is 3. And I'm listing it down for each one just so I can remember that that's the distance I'm trying to find between each number. So what I mean by distance from mean, it's the amount value amount that is away from the mean. So distance, by the way, is always going to be positive. Distance is not going to be negative. So if I'm finding the distance between 1 and 3, how many units do I have to jump to get to 3? It's 2. Same thing here for my data, for my number 2. How many units do I have to jump to get to 3? 1. Same thing here with 2, 1 again. The distance between 3 and 2 is 1 yet again. Now, how about from 4 to 3? How many numbers will I have to jump to get to 3 from 4? Should have said 1. So it's the same thing for 4. So all those 4s. And then what amount of units do we have to jump to get from 5 to 3? It is 2. So we have 2, 1, 1, 1, 1, 1, 1, 2. Okay, So that's the amount we're going, that's the amount, so the distance from mean means what amount of units do we need to jump to get from the data set to the mean. Okay, so from 1 to 3, it's 2 units. From 2 to 3, it's 1 unit. From 2 to 3, it's 1 unit. From 2 to 3, again, 1 unit. 4 to 3, 1 unit. 4 to 3, 1 unit. 4 to 3, 1 unit, and you get the picture. Okay, so go ahead and that's just, again, my dog making a lot of noise. So go ahead and move on to the second part of this video to move on to step 3 and step 4 and to get some more examples of how to find MAD.